So I'm here with Ian, and we're coming into the second pig enclosure. And what is it that you want to talk about today, Ian?
Well, we could take a little tour of our paddock. We have this property out here by this creek, and we've divided it into several paddocks, and we're employing different permaculture techniques that people might be interested to see and hear about, because they were pretty radical when we learned about them.
What is permaculture?
Permaculture is a form of agriculture that's focused on self-sufficiency, sustainability, being carbon negative, and being a form of agriculture that contributes to rather than depletes the biodiversity of the ecosystem that you're in. And we live in a very, very diverse and delicate ecosystem here.
So what are we going to talk about first?
Well, we could talk about, so this is our pig paddock. It's about 1/4 of an acre. This is the pig's little hut right here that we built out of a geodesic dome. And we're using a type of, we're sort of pioneering our own form of green architecture using a fig tree. It's defoliated right now because it's dormant, but fig trees are natural epiphytes, and they have roots that sort of form a cohesive mat. They're related to the stranglers you see in the rainforest, which ensnarl trees and form these cages, which eventually envelop and then form a structure all on their own. And so we're trying to employ that. We learned about all this when we went to Cambodia and saw all the fig trees growing over Angkor Wat, you and I. But we're trying to employ that on kind of a small scale. This is a prototype, and if it works, it's a form of low intensity construction where the structure, in theory, grows over time and heals and produces for other species and provides shelter. And so far it's working. It's in its second year now, and without a doubt the fig roots are completely ensnaring the structure. If I could go back and do it again, I would have covered it with a plastic tarp that was clear so we could watch the roots grow. But I've created new prototypes elsewhere, and I've done it that way so we can get some documentation of that in the future.
You said that figs are epiphytes. What does that mean again?
It means they grow on other organisms or objects. So if you tour Spain or anywhere in the Mediterranean, you'll see Ficus carica, which is the common fig, growing out of walls and off of like a lot of human structures. And of course, if you go into the tropics, you see it on a more dramatic scale with the strangler figs. But it's all the same. They're all in the same genus.
Pigeons are one of the species that do that, right? Distribute the figs on top of buildings. And
yeah, figs rely on a lot of seed dispersing species. Pigeons and bats are one of the big ones. So are monkeys in the tropics. Anyways, they support a lot of life. They're the tree of life. There's a really good book about them, God's Wasps and Strangler Figs, that I think everyone needs to read. They're talking about using fig trees to reforest the tropics where human activity has caused devastation. So that's the first project that we're working on. It's covered in all sorts of succulents and stuff that don't need a lot of water, because in the summer this gets quite dry because it's elevated off the ground. And then, so this is a good vantage point for the paddock. You can see that across this is the word I'm looking for. This ley line here, at this elevation, we have this, it's called a swale.
I don't think ley line's the right word. That's
Yeah.
like a magical term. Well, it's a contour. It's
Yeah, contour line, thank you. So we had a bunch of biomass just laying around from when this place was logged, and so we took it and we built these berms, they're called swales, along the contour lines of the property, and we put animal traffic behind it. So each paddock is kind of a terrace, essentially, and the animal traffic behind it produces sort of a leveling out of the elevation, and it kind of terraces the land, and the swale prevents any erosion. Any erosion that occurs stays within the property, and there's no erosion off of the property itself. These are our native maple trees. They're called the big leaf maple. They're beautiful, but they're kind of like, using the word weed tree would be derogatory, but they're kind of in the way for what our purposes are, because we're growing a orchard here of food producing trees, including figs, chestnuts, walnuts, and several other things. And these are kind of competing for space. But the thing about these trees is you can cut them down and use the wood to feed the mycelial network. We just sort of lay the wood down and use it to feed the mycelial network in the ground. And it doesn't kill the tree keeps sprouting up from the base, and then we can go in after a few years of allowing the growth to just come up and cut it down over and over and over again, basically for the rest of time. And that will provide an endless source of carbon that we use to feed the mycelial network that supports the trees we actually want. And in these trees, so this is a second growth maple. This was cut once upon a time. Here's the old rotten center. You can barely differentiate it from earth. It grew up, after it was cut, it grew up once. We could cut it down again, and it could do it a million other times. But in this rotten center, throughout all the maples on the property, we've planted, again, fig trees, because they're parasitic epiphytes. So eventually, when this fig tree gets cut down and exhausted by this process, we'll have a huge fig tree growing up here where once stood a maple. So nothing will be lost. The canopy will not shrink. Every tree that's lost is replaced.
And this, I'm going to zoom in over here. So that stump over there that's got like twigs growing out of it, that's a maple that was cut down just a few years ago. Oops, sorry, I panned off of it. But that's a maple that was cut down just a few years ago. And like all those twigs that are coming out, those are new branches, essentially.
That's 1 year's growth.
1 year's growth.
1 year's growth.
Because you cut that back last year, didn't you?
Last year I cut that back. They grow back like crazy, so I don't feel terribly guilty cutting them down. Unlike conifers, which don't generally come back at all from the stump. Like, here's the cedar. This is the cedar stump. The tree is absolutely dead. But all these cedar stumps have rotten cores, so we planted fig trees in them because, again, they're epiphytes. And we found this actually works incredibly harmoniously with keeping pigs in this area, because the pigs can't hurt them. Pigs like to root around, and if you plant them in these stumps, which we did, and we have like 50 stumps around here, we've planted so many fig trees, the pigs can't get to them, and the fig is living in a fashion that it's evolved to, which is epiphytically up off the ground in rotting wood. It's perfect for them.
Right behind you is a hemlock growing out of a cedar stump.
This is like a beautiful example of what these might look like, I don't know, 50 years from now. Hemlocks have the same behavior, the same epiphytic behavior. You see this in rainforests a lot because nothing wants to go to waste. Look at all that carbon material. They have a symbiotic relationship with wood-eating fungus, so they can actually, back when this was an old-growth forest and it was shaded out by cedar, which is what it used to look like, this hemlock would have been a low-growing little twig out of this dead stump, and it could have hung out in the shade for centuries, waiting for a clearing in this canopy, and it would shoot up at that point. And the way it can sustain itself in such low light levels is it has a symbiotic relationship with like reishi mushroom and those other mushrooms that eat wood. So they kind of help compensate for its lack of light. It's an incredible symbiosis.
And this tree, even though we're calling it hemlock, that's kind of the common name for it. This is an example here of a bigger one. The western hemlock, it's called that because I guess it kind of smells like poison hemlock or something. I forget exactly what the explanation is.
It's not poison hemlock. That's something else entirely.
Yeah, it's a totally different plant.
It's in the...
The more accurate name for this is Tsuga, Tsuga.
Yeah. And then, so here's another species we're working on. I know we talked about this before, but this is the Araucania, I think Bedwilli is, I don't know if I've got the species name right, but the genus, it's the same as those Norfolk Island pines. It's in the same genus as those little Christmas trees you see in the grocery store with the really, they've got those beautiful slender branches. This is related, except it's very, very sharp. And it's the only tree we grow that we don't have to fence in because it co-evolved with dinosaurs and it can handle itself just fine. And when they're mature, they'll produce pine cones the size of basketballs. The Aboriginal people in Australia have a similar species in the same genus, different species. It's called the bunya bunya pine. And they used it for self-sustain. They sustained their entire civilization on the pine cones of the bunya bunya pine. This has a similar quality to it, but it's a little more cold hardy, so it's more appropriate for the Pacific Northwest.
Is the bunya bunya, is that the one that you have to like soak in a river or something like that?
Oh no, you're thinking of the Moreton Bay.
Oh, the Moreton Bay chestnut,
which
right?
Is a legume, and it's highly toxic. It's got like a compound in it similar to ricin.
Okay.
But that's also, yeah, the Aboriginal people use that too, but we don't have that tree. But this guy, they're very slow. They're dioecious, so the male and female are separate. We don't know what gender they are until they're 15. So we planted a lot to play the odds, and in theory, 50 years from now, they could support a pretty healthy family. It's a good survival crop. Yeah, it's a reliable food source. They're wind pollinated. We don't need to rely on pollinators for them. So it's a good tool for producing food in a world where we might have depleted pollinators. Here's another
We can make
one.
a lot of pesto.
Yeah, whatever you can do with pine nuts, you could do with those. But the pine cones are like basketball size, and the nuts are like huge. So like utilizing it is easy as opposed to some like smaller pine nut tree. These are chestnuts. Chestnuts are another tree that could help civilization change course a little bit. What differentiates chestnuts from ordinary nut trees is that the nut has the same nutritional profile as corn. It's not really a nut in the sense that a walnut's a nut, which is high protein. It's a nut in the sense that it's a starch. It's the starchiest nut. If we replaced corn crops with chestnuts, we could suck massive amounts of carbon out of the atmosphere. We could support biodiversity. We could have a sustainable form of agriculture en masse. And although monocultures aren't good, chestnuts are accustomed to growing as a monoculture in their natural setting, so it could be done that way safely. One of the problems with chestnut is the chestnut blight. They're susceptible to a fungal blight, at least the American chestnut. But this is a Japanese-European hybrid. It doesn't have that problem. They've overcome that. There's lots of different varieties now that have overcome that problem. They're reintroducing even the American chestnut. They've genetically engineered it to be immune to the blight. So yeah, if we focus more on growing chestnuts as a primary grain as opposed to corn, if we get away from grasses and we start utilizing trees, and chestnuts would be the tree to go to, we could really flip the script on how we mass produce food.
Chestnuts roasting on an open fire.
Well done.
What's next? Jack Frost nipping at your nose. It's been said many times, many ways.
You're not going to get me to sing on camera.
Yeah, I'm also like way off key there, but I tried.
Well done. So what else? I mean, we have this on many scales. We have a diverse. We're trying to support diversity here, so we don't have a monoculture. Our main trees are chestnuts, these monkey puzzles, figs, which are a keystone species. I could spend a whole hour talking about fig trees. You can regenerate entire ecosystems using fig trees, but I just don't have the time to talk about that right now. And persimmons are another tree we're utilizing, although we don't have any in this paddock. And one of the reasons they're a good tree to utilize for long-term sustainability is the fruit lasts a really long time on the tree. Persimmons are actually a giant berry. They're distantly related to blueberries. They're actually a type of ebony. The wood is like really hard and black. It's amazing. And so the tree produces a very dense wood, which actually is another way of thinking about storing carbon. These trees that produce really dense woods store a lot of carbon. And persimmons fall into that category. And they produce fruits that can hang on the tree for months. So unlike plums, or any stone fruit, which they have their season and then their season's over, persimmons, the season is all winter long. You can leave them in the tree. They'll slowly kind of raisin over time, but they're always good. They just get more ripe and more ripe until they're kind of a raisin form. And they're very good for wildlife. So that's sort of the main fruit tree we use, aside from figs. Yeah, I think that's good. That's a good summary, right?
Yeah. So yeah, thanks for talking about all this today.
Sure. Thanks for interviewing me.